Hello everyone. Today I will discuss on shear strength of soil. So before I am going to the shear strength of soil, I want to share some formula. Here is some formula you can see here. Shear strength of soil, tau equal to C plus sigma into tan phi. C equal to sigma undrained divided by 2, or sigma equal to undrained divided by 2, and or we can find out C equal to 300 SPT and 60, which is called PSRM correction divided by 2, or we can find out C from drawing circle, and this position will be C, or you can find out the C, but it is not appropriate because this formula will not appropriate for finding C. Here is another formula, sigma 1. Here is a sigma 1 is a particle load equal to sigma 3. Here is a sigma 3, and delta sigma is a deviator stress which is applied on vertically on sigma 1, and sigma 1 prime equal to sigma 3 prime tan square theta plus 2 c cos square theta, and sin phi, here is a important formula, sin phi phi equal to sigma 1 minus sigma 3 sigma 1 plus sigma 3. So in this way we will find out the angle of phi. Here we can see here is a lots of circle, but circle will be start here from C1 sigma 1, and this will be sigma 2, but not this sigma 1 and this sigma 2. This because this is the derivated from BM dash or some researcher. The circle will be at the right side will be sigma 1, and the left side will be sigma 3. Okay, theta equal to phi by 2 plus 45, and phi equal to 14 root over 20 into n160, which will found from BSRM correction, and sigma equal to sigma 1 plus sigma 3 divided by 2 plus sigma 1 minus sigma 3 divided by 2 into cos 2 theta, and normal stress here is the principal stress is vertical, and normal stress is principal stress is here when the load is applied vertically plane is a major stress, and when the load is applied laterally, then it is called normal stress. So normal stress, this is the normal stress. Normal stress sigma at failure, sigma 1 equal to sigma 1 prime plus sigma 3 prime divided by 2 sigma 1 minus sigma 3 prime divided by 2 cos 2 theta, and shear stress T equal to at failure mode tau equal to C1 minus C3 C3 divided by 2 into sigma theta, and principal stress I have already said here is the principal stress or major stress sigma 1 or sigma 3 sigma y plus sigma x is divided by 2 plus minus sigma y minus sigma x divided by 2 plus tau xy, and normal stress we know sigma y plus sigma x square. This formula we have taken from solid mechanics 2, and we want to deduct, but we will not this because this is our geotechnical formula. We will use this formula. So let's start from shear strength. The shear strength of soil is mass in the internal resistance of the area that its soil mass affecting the resistance failure and sliding around the plane inside it, and one must be understand that nature of the shear resistance in order to analyze soil stability problems such as bearing capacity, slope stability, local pressure, and absolute. So shear strength is nothing but shear strength is we will use C and phi. This is the main measure or focus how we calculate C and phi. So before we going to discuss, there is a formula we have to discuss. So we know the shear strength. This is the main formula, tau equal to C plus sigma into tan phi. How we'll get the sigma equal to sigma 1 plus sigma 3 divided by 2 sigma 1 minus sigma 3 divided by 2 into cos 2 theta. So sigma 1 is major principal stress. I have already said the major stress is here, and sigma 3 is a minor principal stress, and sigma 1 prime effective and sigma 3 is a effective minor. Okay, so we can use dia which is sigma 1 minus sigma 3. So we can, if we go this here, so we can use sigma 1 minus sigma 3, then we can use the dia which is called also deviator stress, which is sigma naught. Okay, so we have seen here sigma prime equal to sigma 1, which is sigma 1 minus sigma 3 plus sigma naught. These are the main basic we have already known. And sigma prime 1 equal to sigma 3 tan square plus 2 theta. Sin phi equal to sin 1 minus sin 3 sin 1 plus sin 3. This is the we can use the, in this formula we can find out the internal angle. And sigma prime equal to, and the effective pressure, then will be adding sigma 1 minus sigma 3 2 divided by sigma 1 plus sigma 3 plus 2 into sigma del EU. So cell pressure is sigma 3 we know, and deviator stress is sigma, and this is the basic formula, sigma 1 equal to sigma 3 plus delta sigma. Delta sigma is a deviator stress and cell pressure is sigma 3. And when sigma 1 and sigma 3 is given, then we can find out the normal stress in this formula, otherwise we will not use. When the is given the sigma 1 and sigma 3, then sigma prime equal to sigma 1 plus sigma 3 prime divided by 2 plus sigma 1 minus sigma 3 prime divided by 2 to cos 2 theta. And shear stress at failure mode, which is 0 plus sigma 1 minus sigma 3 divided by 2 sin 2 theta. So we can see the principal stress, sigma x is y, sigma a. These are from the solid mechanics. We will not use this. So the value of sigma we can find in two way. One is this, drawing the circle, then we will calculate the c, and otherwise in this equation, but the equation is not appropriate. So we can see here the Mohr-Columb failure. The Mohr-Columb presents the theory of the rupture material that is consistent in the material because of the at the criteria there's normal stress and shearing stress is not from the maximum. So these are the Mohr-Columb failure, tau equal to c plus sigma into tan 2 theta. So here I have been here. So this is coming from also linear function. We know y equal to c plus mx. So this is the basic from coming from tau equal to c plus tau tan theta. So you can see here another graph which is the x-axis, y-axis, and sigma stress, and this is the C point, and y-axis is the shear stress and axis is in normal stress, and Mohr circle failure is this line, and this is the angle. So we can see here the circle, this is sigma. We can, if we focus this circle, then we will see the right circle position is sigma 1 and left side is sigma position 3. So remember it, this is 1 and this is 3. So and this will be and the particle position will be C. On the silt clay cohesive soil, then C will be value will be C. When the sand and gravel or cohesion less, then there will be no value of C. Okay, so we can see here tau equal to c plus 2 prime. We can 2 theta. There is another formula. 2 theta. This is the 2 theta equal to phi plus 90 degree, or theta equal to phi by 2 into 45 degree. This in this way we have find out the theta is phi by 20 degree. So let's see an example. This is our soil properties and given. Draw the Mohr circle from this way. The data is given here, and 250 is given, 100 kPa is given, and this is the major principal and this is the minor resource. So what is the diameter? We know the diameter will be, this is the sigma 1 and this is the sigma 3. But before going to here, we know that this is the sigma 1 and this is the sigma 3. So sorry, this is the sigma 3 and this is the sigma 1. So diameter will be, this is the diameter. When we will deduct the diameter 250 minus 100, then we will get the diameter is 150 K. So 150 is answer. Another, draw the Mohr circle Coulomb failure when phi equal to 45 degrees. So we know the angle, but we have to calculate the sigma, which is found is 75. How we'll get the 75? We'll drawing this circle at first. At first we draw the circle, then here we can give the sigma 1, which is 100, is given here, and sigma 3 is 250 is given here. Then we will calculate the diameter. Then we found 130, and we will calculate the radius. Radius will be 150 divided by 2, which is 75. So this is the 75. So the this point is 75. So we know this point is the value of sigma. So that's why we will find the 75. This is the 75. So now we'll putting this formula, tau equal to phi, tan phi equal to 10 phi. So sigma is 75 we have found here, and angle is given 32, and in this way we will found tau equal to 46.86. So this is the shear, which is found 46.86 kPa. And number 4, calculate the angle of the friction of the file. So we have to calculate the angle of the theta. We know the theta divided by 45. If we go to the here, this formula we have used, then we have found the 61. 61 is nothing but this angle is 61. This angle is 61, and 32 is given. 32 is given this angle or this angle, 32, and measure principal stress is given, which is laterally is applied third for 100 kPa, and minor is we have seen the minor is lateral, and major is the vertical. We have seen 250, and coordinate of pole is 100 into 0. We have found here. I will get the 100 into 0. This is the 100, and shear stress is 0. That's why we have found the 0. So we can see the laboratory test of determining shear stress C5. So the laboratory tests are following, which is a direct shear test and triaxial test. Triaxial test are 3 types, which is direct sample shear test, plane shear test, and torsional learning. Triaxial test is generated here. We have been seen here. This is the graph, is the year, this is the year, and this is the pipeline which is connected for drainage or pore pressure measuring. So there are 3 standard type of triaxial tests are conducted, which is consolidated drainage test, which is CD, and consolidated undrained test, CU. This is the very important, and we have used this, and unconsolidated undrained test, which is EU. And triaxial test we have seen here the cell pressure is sigma 3 here. So this is the soil property. Soil properties in vertical and horizontally cell pressure is applied, and the vertically we have used the deviator stress. So note that the soil never be failed unless we will apply the deviator stress. When we will apply the deviator stress, then soil will be failed. The cell pressure we know, sigma 3 consolidated and unconsolidated, and delta sigma is drainage D and undrainage U, and drainage D prime and undrainage D. 3 type of triaxial tests, which is CD, CU, and EU. We know the CU is the deviator stress. Here is we can see the diagram. We can see this sigma 1 minus sigma 3. This is dia, but it is called deviator stress. We can find out this deviator stress. So these are the formula we have seen here. Deviator stress sigma 1 minus sigma 3. But we'll okay. So let's see the unconfined compression test in silt clay. This is only for cohesion lashes, silt and clay. So we have been seen here tau equal to 5 by 2 and at q by 2 and cu. So we can see here the dia sigma 1 minus sigma 3 is qn. So q1 equal to 2 cu. This is the cu, which is radius. So if you calculate the cu, then q divided by 2. So we have written here at first. This is our formula, c equal to q divided by 2, but we have found this here, and the dia is found sigma 1 minus sigma 3. This is dia of q, and q will be double of cu, because this is the radius. Direct shear test we have known here. The profile is given here, I am not explaining. Direct shear also, this graph we have to stress. The shear stress is given y-axis, and shear displacement is given is x-axis, and peak shear strength is given here, and dense sand in ultimate shear strength is here, and loose sand is given here. So we have to see the another graph is sigma 1 is greater, sigma 2 is then less than sigma 3. That's why I have said that the sigma 1 will be right side, like this way. This way will be sigma 1, because the sigma 1 is greater than sigma 2 than sigma 3. So we have been seen here the axial deformation, which is compression or tension. Here is a expansion, and here is a compression. When the dense soil sand, that will be expansion. When the loose soil, that will be compaction. This graph, the void ratio is given here is the loose soil, and there is a dense and ultimate soil. So let's start from our calculation or math example. Draw the mesh circle. We have been already calculated here, and that's why I will not calculate again. Okay, so let's see here the coordinate. The consolidated drainage triaxial tracks was conducted and a normal consolidated clay. The result are the following. Sigma 3 is given, sigma 3 here, sigma 3 will be here. Okay, 270 kilonewton per meter square, and delta sigma is 276 also. Determine the angle of friction, which is phi, and angle theta, that is failure plane mixed with the measure principle, which is measure principle in this way plane. For the triaxial test, we know the effective measure stress is sigma 1, and the failure is, we know that sigma 1 equal to delta 3 into sigma 3 into delta sigma. So these are the measure formula, and we have used sigma 3 and delta sigma and found 550 kilonewton. And for the triaxial test, the effective minor stress, which is sigma 3 as the failure mode, we know sigma 3 into sigma prime with sigma 3, which is 270. So these are the measure. We can see here the sigma 1. We have at first we are drawing the circle, then we will do the sigma 1 prime, which is 550. Is the 550. This is the sigma 1, and sigma 3 prime is 276. Here is the 276. So sigma 1 is must be greater than sigma 3, and we have found that angle. You can see this is the graph. This is the sigma 1 prime, and this is the sigma 3 prime, and this angle will be theta. Okay, so find the I will use the this formula sin prime. We will go to the this formula sin theta or sin prime. Then we'll use sigma 1 minus sigma 3, sigma 1 plus sigma 3, and found the angle, which is 49.45. So this angle is this angle, or we can say this angle, which is 19.45, and theta equal to 5 by 2 into 45. If we go to the formula sheet, then we'll see the number 4, and found 54.73. This will be 2 theta, and this is the theta. So we have found 54.4. We can see another example, which is consolidated drainage triaxial test was conducted on the normally consolidated clay. Sigma 3 is given here, and delta sigma is 273. Determine the find the normal stress sigma prime and shear stress prime on the failure plane, and determine the effective normal stress and maximum shear stress. Okay, let's start. We see the sigma prime and sigma we know the sigma 1 equal to sigma 3 divided by delta sigma, and in this way we found the sigma 1. And the triaxial test at the failure mode, sigma 3 equal to sigma 3 prime divided into sigma 3 and found 276. And in this way we have found the sine angle and found 19.45, and we will find that theta equal to 5 by 2 into 45 as it is previous math, and found 54.73. the normal stress prime at failure mode, how we'll get, this is the formula we have found. Sigma in this formula we can found here sigma 1, this formula we have used, number 6, normal stress at failure, sigma 1 plus sigma 3 divided by 2 sigma 1 minus sigma 3 and 2 cos theta, and found 368 kilonewton. And shear stress we know at the failure mode, number 7 we have used formula 7 and use 130 kilonewton per meter. These are the our answer. And we can see another example. The specimen is situated cell and consolidated. This is the cell and the consolidation and all around pressure. That means the cell pressure, which is sigma 3. We have to understand the language. And the triaxial test was conducted in case the drainage was prevented or the specimen failure at the axial behavior. And the deviator stress is delta sigma, it is 70, and the pore water pressure at the failure mode was pore water pressure delta U given is 50. Determine the consolidated undrained shear strength of phi, and the drainage function is angle phi. So this sigma 3 and delta sigma and undrained and del U is given here. So let's start. We know the basic formula, sigma 1 equal to sigma 3 plus delta sigma, and in this way I found the sigma 1 which is the axial root will be also, and 170, and we will use the sine this formula and found the angle is 45, and this is the 45 angle we can see here. But the drainage function of angle, two angle we have to found. The consolidated undrained shear angle, which is there is no prime. On the other hand, we can drainage, which is the angle prime. So angle prime will be sigma 1 minus sigma 3. This is if we angle prime, this is the formula of 3 B, which is used to drainage. So we will use the to drainage pore water pressure, then found the 23. This 23 is a phi angle prime. So this, if we go to the picture, then we will get the prime is, the angle is prime is greater than the angle of normal prime. So we can see another example, which is the from a serious triaxial test, Mohr-Columb failure envelope. So soil was C equal to 30 into phi equal to 45. The failure effective minor principal, we know the sigma 3 stress is 300, and determine the effective Mohr principal stress and deviator stress also. Deviator stress at failure and effective stress, and determine the inclined angle of the failure plane with the major prime do the Mohr-Columb, and B will be the consolidated drainage triaxial test when conducted in a normally consolidated clay specimen under a confined pressure of 375 kPa, and at the failure of deviator stress is 225 kPa, and compute the effective angle of the internal friction. So let's start. So we know the data is given C equal to 30. If we go to the here C equal to 30, and angle is given is 25, angle is given 25, and sigma 3 is 300. Here is a minor is 300, sigma 3 is given. So if we calculate here, if we draw here, say sine phi, which is sigma 1 minus sigma 3, and in this formula we will found the sigma 1 is 740. So sigma 1 is here. Now we will draw this circle and found sigma 1, which is 740 kPa, and we will use this formula, sigma 1 equal to delta sigma sigma 3 plus delta sigma, and found delta sigma is 445. So 445 is a dia. So if you deduct the and 0 minus 445, then we will get the sigma 3, as sigma 3 is given, so we will not calculate back calculation. So we will found the delta sigma, which is diameter, and theta equal to 5 by 2 into 45. Phi is given here 25 and found 57. So this in this way we can see here the theta is 57 and sigma 3 is here and sigma 1 is vertically and phi is 25. So these are the first answer. And the effective measure principal stress, deviator stress. Here is a deviator stress, and effective stress is here sigma 1. And the principal failure with the minor pen, draw the Mohr circle. Here is our Mohr circle. We have been drawn here as this will be 30, because the equation is given here, the value of c, and this is the value of phi. So these are the Mohr circle drawing. So we will answer this, and now we will answer the question B, which is sigma 3 is given 375 kPa and delta sigma is found 7225, and sigma 1, if you use this and found sigma 1 equal to 600, and in this way we will use sigma 5, and we will found the angle is 30.44, and theta will be found 51.67. So these are our answer. Or we can use this way to get the answer, which is sigma 1 equal to sigma 3 prime into 10 square theta into 2c into 10 phi. The given sigma 3 is given 300, sigma 1 is we have to calculate sigma 3 into calculate, and we have to calculate here, and in this way we can use this formula also, and found delta sigma is here too, and theta is found here. Okay, let's start another example. Here the consolidated undrained, that means C equal to 0, test was conducted on the clay sample. The following result were obtained. So cell pressure is given. Cell pressure is 3. We know if we draw the soil property, these are the sigma 1 and this will be sigma 3. These are the cell pressure. So cell pressure is given, and deviator stress at failure mode is given. All the specimen deviator stress is also delta sigma, and the pore water pressure is given here. So draw the Mohr circle at failure mode. At the test is the shear strength C5 with the respective stress of the effective stress as the graphical method. So we know the sigma 1 equal to sigma 3 into delta sigma for 1, and found 318. So we know the 3, and we know the sigma 1 318. We know the 318, and sigma 3 is 200. Sigma 3 is 200. Then we can found delta sigma or dia, which is 118. And from this this is based on the first information. We know the sigma 3. This is the sigma 3, and delta sigma is 118, and found dia. And from second information, sigma 3 is 400 and 400, and delta is 420 and 420, and found 640, and dia will be 240. This is the second information. We know the sigma 1 equals to 600 here. Sigma 1 is 640. Here is 640 sorry, this will be 640. I am using this value because we are drawing this graph 640, and sigma 3 is we have found sigma 3 is given here 400 is a 400, and we can deduct this value from, and found the dia will be 240. And in this way we will calculate the third graph. We know the here sigma 3 is 60. There will be sigma 3 60. This circle, these are the sigma 1 and these are the sigma 3 is a 600, and delta sigma is given, and sigma 950. So this will be 950, and the dia will be this dia. So dia will be 350. And we know that sine equal to sigma 1 minus sigma 3 and sigma 1 minus 3. If we deduct this and find the angle, which is 30.16, the 30.16 will be the angle, and theta will be 51.54. So if we go to the this angle is the phi 30.16. These are the angle of 30.16. So we can see another example from here. These are our last example. So we have seen here the angle of internal friction. Angle of internal friction is 30 is given, and maximum principal stress is 70 at the failure concealed soil and submerged by 2 meter water, and minor stress is what? Mohr-Columb we have to do. So we know the here is a given the internal friction is 30 and sigma 1 is principal stress we have given here. We know the principal stress sigma 1 and the minor stress is sigma 3, and we have to calculate sigma 3. So let's use this formula sin theta sigma 1 minus sigma 3 and sigma 3 plus sigma 3, and found sigma 3, which is 2333. So we know the sigma 1 is 70. Here is the sigma 1. If we now will draw this circle, and this is the sigma 1 and this is the sigma 3, we have found 23, and the dia will be 70 minus 23, which is 46. 46 is will be we will use this sigma 1 minus sigma 3 delta sigma, and found 46, and radius will be dia divided by 2, which is 23.33. This is the radius, and theta will be 5 by 2 into 45, and found 60. Now we'll use tau equal to 2 into sigma into tan 2 theta. Sigma equal to sigma 1 minus sigma 3 divided by 2 into tan theta, and found sigma 1 minus and this in 13.46 this, and this is the angle we have found. At first we have found the angle is given 30. This is the angle 30 is given. Okay, we have seen here the theta we have found here. How much is 60? The theta is 60, and sigma 1 is here given, the sigma 3 plus sigma delta sigma, which is the cell pressure, and plus deviator stress. Now we can see another example. The cohesive soil is example, as an angle of internal friction is phi is given is 30. Phi is given 30, and the cohesion of 28 kPa, which is means C is given here, and the maximum shear strength is soil equal to 60. So tau is also given here. What is the confined pressure, which is sigma delta sigma 3 is for the cell for the failure is occur, and solve the maximum principal stress at the causes to failure, and determine the normal stress at the point of the maximum shear. So we have found this formula, and we can see this is our maximum tau is given, and we firstly we draw the circle, then we have maximum stress is given here, tau is 60, and we can compare with we want to we want to find this position. Then what we will to do, then we will continue compare with cos theta sigma this point divided by maximum, and found sigma phi equal to 51.6. This point is data is 51.96. So we can see another now we can compare it to equal to mx, but we don't need this. This is the formula tau equal to 2 plus c plus sigma plus tan phi. We have used the recent this tau value is 51.96, and found the sigma equal to 41.6, and we will use the formula of sin x. This we know that this is our triangle, and this is the theta. So this is our height, and this is our hypotenuse. So sin theta equal to height into hypotenuse, and this is and we'll use all these value and found the x value. X value means this point. Okay, so 30 we have found. So let's draw this diagram. At first we will give the x-axis and draw the circle. Circle is here, we have been drawn, and we know the sigma 1 is 41. 41 is given. We have found how 41 is found. This is our 41. So we have found this point, and this axis is 41, and we know this value is x. So x sigma plus x is will be 71, and this portion, and we will also know the max position. This value, this distance sigma tau, and this distance will be same. That's why we have used this and found 313. So this point will be sigma 1, which is 313, and if we deduct the value of tau, all the value of tau, then we will found the sigma 3113. This portion is sigma 3. We know sigma 3. How we'll get? we have know the sigma plus tau from this point, and then we will deduct the value of this tau, because the radius is same. This distance and this distance same. Also this distance same. So we know that this point, which is 113, 41.5 and 30 minus 60. Then we found this portion. So we know the three answer: 11.1 kPa, 131.5 kPa, and 71.5. So you have to must understand this graph, and this is the tau max, and these are the tau, because the radius is same. But this is the another tau which is vertically, which is positioned in this way. So these are the angle is given 30. We know the question is given here. So you can see another example. The following results are obtained from triaxial test and normal stress consider. Plot the strength in terms of the total effective stressor and determine the cohesion angle of internal friction. So these are the diagram is given there. Cell pressure, which is sigma 3 is here, it is given here, and deviator stress we know here, deviator stress is given, and prototor pressure is given here. So if we use the first formula, sigma 1 equal to sigma 3 into deviator stress, sigma 1 is 50 and plus 180, and this is the 180 is given, and 220, and this we now will draw this first circle is here, and sigma 1 230, these are the sigma 1 230, and sigma 3 is 50, and sigma 3 is 50, and the dia will be there, as we have already know the 230 divided by 2, and then will be dial 115. Okay, so this is our second graph we have been drawn here. Sigma 1 plus sigma 3 in this will be from sample based on sample 2. It is given sigma 3 is here, and the deviator stress also 320, and found sigma 1 equal to 420. So this point will be 420, which is sigma 1. I'm changing. If I will change the color, then we can see this our circle, and this will be our sigma 1. We have found 420, and sigma 3 is found here 100, and the distance of dia is 320, and the radius will be 320 divided by 2, and the third in the base of third information we have found that sigma 1 is 600. So we can use another another color for more understanding or better understanding. This is our circle, which is sigma 1 we have found 600, and sigma 3 is 150, sigma 3 is here, 150 is given. So if we deduct 600 minus 130, then we'll found 450. This is our dia. But if you want to calculate the radius, then radius will be 450 divided by 2. So these are not, I think these are not accurate, because dia is given 180 is given, and 180 divided by 2, it will be 90. Radius will be 90. This radius will be 116, and this radius will be 450 divided by 2, which is 2205. And angle will be this formula we will use, and then angle will form 45. This is 45. So and theta will be angle divided by 2 into plus 45 and for 65. If we intersect this 3.1, 2, 3 and draw this line, then we will found this value of C. So we have to must understand that C will be found from the graph from drawing the 3 circle of the intersect point, then we will found the C value of 25 from the graph. So we can see this is our last math. So from the following graph, the determine the cohesion of C and the angle of internal friction. Here's all the data is given. The shear stress is y-axis and normal stress is x-axis. So the data we've been found tau equal to C plus sigma plus tan phi. We have been found from C is 40, and tau equal to 200 we have been found. These are the graph is ended here, so that's where we have found tau, and C is found in this 40 and 20, and stress is found 40, and tau will to 120. I will get 120. This is our maximum value of stress. There is a 120, and this line is given. From this line we have found the sigma is 200, and phi is C is found 40, and tau is found 120 is a maximum value from this line. Now we'll use this tau equal to C plus sigma plus tan phi, and found that angle which is 21.8. So angle will be, this angle will be 21.8, and C we have been found from this graph already 40. So this is our lecture. If you have any question, let me ask or draw or question right here. I will try to solve your questions. So if you have any question, then let me know. Thank you everyone for your patience. Thank you.